Okay, so this final problem set should be a little bit more fun because we work with real-world data. So we are supposed to download from the WDI for the 217 countries in the year 2020 the following series. So school enrollment, tertiary gross gender parity index, that basically gives you the ratio of girls enrolled in tertiary education relative to the boys. So the greater that number is, the more women are enrolled in tertiary education. And the second is the adolescent fertility rate. So let's see if there is a relationship. So the first thing is we go to the WDI, which you see here to the right. We first click on the countries, and let me see if I can also activate actually my keystroke here quickly. Okay, so now you can see my keystroke. So we select first the 217 countries. Now we go to series and we select, we can search for gender parity or gender. So now we go to S, school enrollment. And it is here school enrollment tertiary gross gender parity index GPI. So we click on that, that's the first one. And then the other one is adolescent fertility. And then we have it here, adolescent fertility rate, birth per 1,000 women ages 15 to 19, so that's the second. Then we want the year 2020. So we select the year 2020. And then we click on apply changes. And let's just, then we go to download. We go to advanced options, and then what you always want to do is you want to download it as a list, because then we can more easily sort it. And in this case we don't need the metadata, so we just download that. Okay, so now it is downloaded. I can open it. And that is what it looks like. And so now what you can see is, let's first fit everything to content. So you see for each country we have now school enrollment, adolescent fertility rate. But what I will do is I will just sort by series name. And then actually I'll just copy everything into a new sheet and I share that file with you. So this is the way you downloaded the data. So I renamed that original data. Okay, so now sheet 1, I call that modified data set. Okay, so now in the modified data set, we sort by the series name, and then you will see what will happen is we don't have any more school enrollment, adolescent school enrollment, but it will be sorted. So we go to data, sort by series name. Okay, so now we have the adolescent fertility rate and the countries are still sorted. But if you don't trust the sorting, you still can double check. You add another level, and then you say, okay, then sort by country name from A to C, but then nothing happened. So now first, those values here in the first is the adolescent fertility rate. Okay. So now if we scroll down, we know the first country is Afghanistan. So if we now search for the next Afghanistan, and I'll just do that by highlighting the column, and then I Control F, and I search for Afghanistan. So now you see with the next Afghanistan, the new series begins, school enrollment, gender parity index. So now I just highlight this entire column below. So I press Shift, Control, arrow down. I cut it out. And now I paste it right next to the adolescent fertility rate. And this column is now school enrollment. Okay, so now I have here some overshoot, because here I cut some data, so I can delete everything. I don't need that anymore. I don't need this column. I don't need the series code, and I don't need the time. I know it is the year 2020, but I can leave it, doesn't matter. And then very often when you work with data, what you want to avoid is very long names. So maybe I just call that adult fertility rate. And this I call tertiary GPI. Okay. And then for aesthetic reasons, maybe you also want to reduce some of the decimal points. Maybe 2 is good. And maybe you want to make the first bold. And maybe you want to have it centered. Okay. So, but the second thing we are supposed to do is we are supposed to eliminate all observations that have a missing observation. It seems that the missing observations are exclusively in the second column, but maybe I have overlooked something, so I want to be certain. So I just create quickly a column and I call it drop. Then I tell Excel if either, so or, if either or this cell is equal to 2 dots, or this cell is equal to 2 dots, then comma, give it a 1, comma, otherwise give it a 0. So now I can copy down that formula, and then whenever we use a formula, it's a good practice to remove it by copying everything over itself. And now I can sort by the column drop, and I push all the ones to the bottom. And then I can delete those observations because I really don't need them. And now I still have some 130 observations. Okay, so now we have our data set. And with this data set, we are supposed to do some things. So we have to calculate for each variable the mean, the median, the range, and all those statistics that we have worked on. So, okay, but we do that in Excel. So I insert here a column, insert, And okay, so now we set the mean, the median, and what else was it? Range, sample variance, standard deviation. Mean, range, sample, variance, sample, standard deviation, 75th percentile, which is the same as the third quartile. The 25th percentile, which is the same as the first quartile. Okay, so now we can just use Excel formulas, and so if you want to see still the first row as we work down there, what you can do in Excel, you can freeze the first row. So there's something view, freeze top row. So now we always see. Okay. So now for the mean, we just use the formula average. And then we highlight everything from E2 to E31, and that's it. And now I can copy this formula by highlighting it, and by pressing Ctrl R, that copies to the right. Okay, so the mean of the adolescent fertility rate is 30 per 1,000 women, and the average actually of the female enrollment relative to male enrollment is 1.7. Okay, so now let's do the median. So now we can use either the formula median, then we highlight everything. So you see the mean is above the median, which suggests that the distribution is skewed to the right. And maybe for the tertiary, I can use, instead of the median, I can also use the formula quartile, inc. And then I want the second, that is the same as the median. If we want to double check, 1.20. If I had used the formula median, .20 as well. So what about the range? The range is equal to the maximum value minus the minimum value. So we can use the Excel formula equals max of this range minus min of this range, and then we have the range, copy it again to the right. Then the sample variance equals variance dot s for sample, highlight the array, 999.32, can copy that to the right. So the sample standard deviation, that would be the square root of the sample variance, but let's just use the formula STD, So standard deviation dot sample, highlight all the numbers, 31, copy to the right. 75th percentile is the third quartile, so we use the quartile formula. Quartile, and you always want it inclusive, comma 3, close, and we can copy that to the right. So now the first quartile, formula quartile, comma 1 for the first, and copy to the right. And then we can also determine the interquartile range, which is simply the value of the 75th percentile minus the value of the 25th percentile. Okay, so now we have all our summary statistics, and there is also an option in Excel. Actually, I can copy this. Maybe here. And I have, you see, when I paste it, I get values because I have this formula. So I should paste it as values. Okay, so this is our summary statistic for the two variables. Okay, there is still something else in Excel, which if you go to data and you activate data analysis, which you activate file, options, add-ins, and then you go to the add-ins, you make sure that the analysis toolpack is activated in Excel. So, but then here you can also, there's an option called descriptive statistics, and you can open that, and then it asks for the input range. So let's do it for adolescence fertility. And then we have to go to the input range, we highlight this, and then we just highlight this range, and then you can have the option summary statistics, and I define the output range, maybe, it doesn't matter, somewhere here. Okay, so now I can cut that and put it here, and then you see you get the same mean, the standard error for adolescence fertility rate, or just, yeah, we didn't talk about the standard error, we do that later. The median is there, so there's more information than what we have here. But if you just want the one-click thing in Excel, you can use this option under data analysis, go into descriptive statistics, and then you get also indicators of skewness and kurtosis and the count. But sometimes you don't really need everything, especially kurtosis and skewness. You don't really report that often, I feel. So the core descriptive statistics are these. And so now we have here measures of centrality and measures of dispersion. And we can also now calculate, of course, other things like the covariance and the correlation coefficient. But before we do that, let's first examine the quality of the data. And let's first take a look at maybe a histogram and a box and whisker plot. So what I do is I don't really need anymore the pane frozen, so I freeze them. So first thing I do is to do the histogram. I highlight adolescence fertility, go to insert, recommended chart, all charts, histogram, and we see it is skewed to the right. So we call that histogram of adolescence fertility. And we can see adolescence fertility is skewed to the right because the mean is really much higher than the median, if you remember. So that's an indicator. Let's do a box and whisker plot. And let's see how that looks like. So we highlight everything, then we insert recommended charts, all charts, box and whisker, and so now we have underneath a box and whisker plot. And we can also sense the right skewness here because those dots that are outside the upper whisker suggest that we have some outliers to the right. So this is a box and whisker of adolescence fertility. So by looking at this data, this would suggest that we probably need to introduce some data transformations, especially if you want to take a look at a nice scatter plot. But let's do a histogram next for tertiary GPI. So we go to insert, recommended chart. First we do again the histogram, all chart, histogram. That doesn't look too bad. So that looks almost a little bit normal. It's maybe a little bit leptokurtic, maybe it's really narrow, but that is histogram of tertiary GPI. And last thing we can do is a box and whisker plot, all charts, box and whisker. Okay, so now you see that this is rather skewed to the left. And there's probably not much we can do in order to make that look nicer. Okay, so that's a box and whisker. For tertiary GPI. Okay, so now by looking at the data, I think it is better to definitely transform the adolescence fertility rate. But if you remember in Excel, when we want to draw a scatter plot, we have to define an array, and the first column is the tertiary GPI, or the first the first column in the array is the one that's being displayed on the x-axis, and I want that to be tertiary GPI because I would hypothesize that a commitment to schooling of girls reduces the fertility rate. So I just flipped them. So I cut them out and put them first. So now let's take a look at what a simple scatter plot looks like. Insert, recommended chart, scatter plot. Okay. Yeah, it's maybe not that bad. It seems like here's a little bit more variation than here. So that's the scatter plot. Let's put it here. But we said that we should probably definitely maybe take the log of the adolescent's fertility rate, so make it look more normal. So I take the natural log and then I call the new variable the log of the adolescent's fertility rate. Okay, so I just take the natural log, copy it down, remove the formula, and now let's take a look at a histogram first. Yeah, it looks a little bit better, I feel. So let's call that histogram of LN, adolescence fertility. Okay, I'll make that here. Okay, so now let's compare what the scatter plot looks like if I have the tertiary GPI on the x-axis, but on the y-axis the log or the linearized data. So insert, recommended chart. Okay, does that look better? Trend line, not really. But that gives you an idea of working with data. So which one is better? Difficult to say. From an economic perspective, I like the transformed one because here we have that problem that we would predict negative values, which is a little bit awkward. Maybe we could massage the data even more, but let's just stop here and let's calculate the covariance and the correlation coefficient for GPI and adolescent's fertility rate. And I freeze again the top row. So view, freeze, top row. And so now I calculate the covariance of adolescence fertility and tertiary GPI. And then I do the same thing for the correlation coefficient. I just call that R. Covariance, formula covariance.s. Okay, so I first highlight the first array, which is now test GPI, then comma, then let's go to the second and highlight the second. Okay. So now I enter the formula, didn't do anything, and again whenever that happens, highlight the entire sheet, then go to Format Cells, and then click on General. And now let's try it again. So now it works. So now you see we get a negative value, which means there's an inverse relationship, and we can see that from the scatter plot, that as the tertiary GPI goes up, the more women are empowered, the less is the fertility rate. So now let's calculate next the correlation coefficient. The formula is Correl, and now we read again the two. Okay, so now the correlation coefficient is negative 0.51, which is actually relatively strong. We can, if you want to, still do the same thing for the log of the adolescent's fertility rate, and then see if we control for this nonlinearity that we observed in the data here, you know, if that makes it, if that gives us a higher correlation coefficient in absolute terms. So let's double check this one. So Correl. So we still have tertiary GPI. Then we use next the log. And then we actually get a worse correlation coefficient. So this could be used as an indicator that you maybe want to stay away from the transformations that we introduced. But anyhow, so I think that should make it clear how to use the formulas in Excel, and you should have now a pretty good grasp on the measures of central tendency, measures of dispersion, but also combinations of the two, like the coefficient of variation, scatter plots, histograms, box and whisker plots. So that should be all part now of your toolkit, and you should feel quite comfortable with it. So I'll just stop here and then let's move on to another topic.